Example number 3 gives us two different functions to differentiate. So this first one I have e to the 3x. So I'm going to go ahead and use the chain rule here. And so I'm going to say so we can think about this thing as being the same as something like y is equal to, e to 3x like that. Okay, it's really irrelevant which way we think about it. So you can either say, well, f prime of x is equal to, but now we have to, it's nice to use this Leibniz notation over here. So you can either say y dy dx is equal to this, or you can say f prime is equal to this. And so it's equal to e to the 3x. Now what we're going to do here is we don't have a rule for, we just have a rule if this guy up here is x, not if it's 3x. So we have to do a substitution here. So we're going to use our chain rule. So let's go ahead and say, let's let u be equal to 3x. Well, once we make that substitution, then this becomes d dx of e to the u. But we can't differentiate with respect to x with u up here because u is a function of x right here. So what we're going to do is use the chain rule, and that is du dx times d du of e to the u. And we know that d du of e to the u is equal to itself, e to the u. Okay, so now we'll go ahead and we're going to find du dx. Well, if u is equal to 3x, then du dx is equal to 3. And so this guy is 3, and then we have e to the u, and u was 3x. So the derivative of e to the 3x is 3 e to the 3x, like that. Okay, let's go ahead and work on part B. So here our function is g, and that's equal to 3 raised to the x, like that. And so g prime is equal to d dx of 3 to the x. And using our rule now, this is going to be the natural log of 3 times 3 to the x, just like that. And so it doesn't matter which order you write it in, your book writes it like this, but it's really irrelevant.